Hello, welcome all of you on our channel Chemistry Academy for JEE and NEET. First of all, I would like to thank you all for your overwhelming response on our introductory video. Today, we are going to deal with one very interesting question that appeared in JEE Advanced 2018 question paper, and the concept it covered was stereoisomers. Now, this particular topic is in fact important for both JEE as well as NEET and require very strong fundamental understanding of three-dimensional structures of molecules. Before moving to the question, I request you all to note down this email ID that I'm marking, chemistry.academy.for.je@gmail.com. You can write to us any of your doubt concerning the video, or you can write any particular type of video concerned to the JEE or NEET syllabus that you consider to be released on this platform. So let's move to the question. The question in 2018 was, for the given compound X, the compound is drawn below. You can see here the total number of optically active stereoisomers. Now, before proceeding to the question, we need to know what is stereoisomer, the term stereoisomer. So let me tell you, the word stereoisomer is such set of isomers which have identical two-dimensional structures, two-dimensional network of atoms attached in themselves, but differ from each other only with respect to 3D structure of the molecules. Such set of isomers are called stereoisomers. They are of two types. It could be geometrical stereoisomer or it could be optical stereoisomer. Now, in this question, we are dealing with both, see, geometrical side and optical sides. But more importantly, the optical is being mentioned in the question itself. They are asking optically active. For a compound to be optically active, to have this term, the only condition that it should meet is the molecule should have non-superimposable mirror image, then it is called optically active. Now, in this 2018, first time this type of wiggly bond appeared in JEE exam, though it is a common practice in very renowned books, but in the test paper, in the question paper, it appeared for the first time. This wiggly bond meant that this type of bond indicates that the configuration at the specific carbon and the geometry of the double bond is not fixed. So, wherever this bond appears, like here and here, so we can have this marked side 3 as wedge or dash as we want to count the total number of stereoisomers. This double bond 2 can have GIS, cis and trans. So as it is having a wiggly bond, it can have either cis or trans. Same is the position 1 can be wedge or dash. But the bonds which is mentioned with this type of symbol, that is a solid wedge, it is said in the question that this type of bond indicates that the configuration at the specific carbon and the geometry of the double bond is fixed. So we cannot move, or we are not allowed to move geometry of A, B, C and D. When I say configuration and geometry, I include the geometry of this double bond mentioned, which I just marked with the purple, right? So we can move only 1, 2 and 3. Now, 3 terms we have used, that is stereoisomers, okay. Geometrical I have just used in describe. Optically active stereoisomers. Now, what is mesomers? So, you may ask that is it possible that a compound is an optical isomer but is still optically inactive? The answer is yes, and then they are called mesomers. What are mesomers? Mesomers are such optical isomers which have superimposable. See, these optically active had non-superimposable, whereas mesomers will have superimposable mirror image. Okay, they will have superimposable mirror image. So, going back to the question, as we have discussed that we can move only 1, 2 and 3 and keep the ABCD sides rigid. What are the possibilities? So, the first possibility, maintaining ABCD as given in the question, is 1 as wedge, 2 as trans and 3rd as wedge. Same, the second possibility I can have is wedge, keeping the first and second as same. First wedge, second is trans and the 3rd is now dash. See, I have changed this only. Okay, so 2 cases covered. Now I will start changing side 2. Wedge, cis and wedge. then wedge, cis and dash. That covered our possibility number 3rd and 4th. Similar proceeding, that first one, now I'm changing it to be dash. See, till first 4 they were all wedge. Now I'm moving it to dash and repeating the 4 combinations that we did with wedge. That is dash, trans, wedge, dash, trans and dash, cis and dash cis and wedge. So as I wrote, so we have got 8 different stereoisomers while doing this whole possible combination. So should the answer be 8? Okay, think that should the answer be 8? Answer is no. We have to check which out of these 8 are optically active. We need optically active ones only. We don't want just the stereoisomers which are optical isomers. For a compound to be optically active, as I said, should have a non-superimposable mirror image. So here you can see that a plane of symmetry, I'm drawing this broken line that indicates a plane of symmetry. What is plane of symmetry? It is a hypothetical plane passing through the molecule such that one half of the molecule is now the mirror image of the other half of the molecule. Or I can say one side of the plane is acting as a mirror image of other side of a plane. So this structure number 1 is having this plane of symmetry. Any molecule that has plane of symmetry behaves as optically inactive, as it will have a superimposable mirror image. It is going to have a superimposable mirror image. So this is going to be optically inactive. As a result, we cannot have this to be included in our total answer. So we had 8, but 1 is gone. Rest all. See, this one is wedge, this is dash, right? So this cannot have a plane of symmetry because the 2 halves should be exactly mirror image. This bond is trans, but this is cis. No, it cannot have a plane of symmetry. This will be included. Trans, cis. Fine, this is already a difference. Then further to add wedge and dash. Trans and trans, but wedge and dash. So this cannot have a plane of symmetry. Wedge and dash. Any difference on the 2 sides will end up closing the discussion on POS, plane of symmetry. Wedge and dash. Gone. Wedge and dash. So we had 8 isomers drawn, but out of this only 7 are optically active. So answer will be 7. Is that clear? So the terms that we learnt in this video are stereoisomers, optically active stereoisomers and mesomers. Hope this is useful for your preparation. This is a very important topic. Please go through it in detail. Now again I'm repeating this Chemistry Academy for JEE and NEET has an email ID that I have again marked here. Please write to us in case you need any particular topic on this platform. Please, if you like the video, share, like and subscribe our channel. Soon we will be coming with few videos on physical chemistry also, as we got request for physical chemistry from some of these students around. Be in touch, keep watching. Thank you.